This is a video showing you how to find an efficient portfolio with no short sales. So we can use solver to find an efficient portfolio with no short sale. But to construct or calculate the efficient frontier, we need to change the value for C and find the best solution or optimized weight for X1 to 4. But can we do multiple times for different value of C? So it's a lot of work. So we will need to use VBA to find possible envelope portfolios with no short sale. So therefore, we can calculate here all these different solutions all at once. So we don't need to manually click the solver and do it for multiple times. Just repeat this process. It's not very efficient, not very time saving. So therefore, we can use a VBA program. So here to run this VBA program, we need to first define the range of results and the cell of constant and the cell of sigma and mean. So we can define it here using the name box. So the result range is here. So we define it here. If you want to add more assets, so you can basically redefine the results, adding more assets here. And for constant, so it's here. This cell is constant. And portfolio mean, our portfolio mean is here. Portfolio sigma is here. And X is here, X1, X2, 3, and 4. So those are specified here. And if you want to add more assets, say if you have a portfolio with 10 different stocks, then you want to add more here and also define the names here in the name box. And then we can basically, to look at the code here, the code will actually call the solver function in Excel. So we need to enable solver in VBA. That's the first step. And then we need to add it to the code so that it can incorporate the model here. And we're going to call Excel to run solver here and output the solution, the result of X1 to 4 here in this result area. So the sigma is here, mean is here, and X1 to 4 is here. So C is here. Excel will just need to, every time it finishes calculation here on this side, and we'll ask Excel to output the numbers here to the result. So Excel will do this row by row. So every row will represent a different value for C. Okay, and then I can just copy the code here to the VBA and make sure that everything is correct here. So the objective is to maximize B19, the theta, by changing 11 to 14. That's good. Maximum is 1, no value of 0. And then for the constant, so the range of constant is defined by these two lines. So it says we want Excel to do a repeated test. So change the constant from here. So when counter equals to 1, so when counter equals to 1, constant equals to minus 0.035. And when counter equals to 40, constant will equals to 16% here. So now the constant will be ranging from minus 0.035 to 0.16. And the constant will increase by 0.005 each time. That's 0.05% each time. So I'm gonna run this code here. Yes, there's an error here. So we're missing one step here. We need to add solver in VBA. So go to tools. So first exit, go to tools, references, enable solver, click OK. And you're going to see there's one more folder here, references. And if you expand it, you're going to see solver was added into VBA. So now we can run this code. Okay, good. So it produced all different values for solving for maximizing the theta given this predetermined value for C. And it is producing all of these results row by row because simply the Excel is changing the constant here and use solver to solve this optimized weight, and I'll put it here.